All right, here we go. This is the study guide for your quiz that you're going to take the next time I see you. You can see that some of it's filled out, so I'll just talk about how I got these values, and then I'll work through the rest of it. Also, you should be able to see that there's a file there that just has the answers. So if you just want to check your answers, close out of this video, go open up the file, check your work. If you want to see how I worked everything out, awesome. If you already checked your answers and you're like, I don't understand this one part, maybe just try to fast forward to where you think I am on the video because it goes in order, right? So anyway, here we go. The first question is talking about a clothing store that earned $20,000 in January. Their goal is to have their earnings increase by 30% each month. Use this information to answer items 1 through 4. So it says write an exponential function that represents this situation where y is the total amount of the store earnings and x is the number of months since January. So what we did, this is a growth, right, because it's increasing. So what we did was we used t for our formula, right? That whole y equals a times the quantity 1 plus r raised to the t. T is the same thing as the x, right? Because we also talked about y equals abx, and we know that a is our initial amount, b is our growth or decay, and then the x is the same location as where the t would be. So in this scenario, x is the same as t, t is the same as x, just like f of x is the same as y, and all that jazz. So I wrote out the formula for growth. I put in the value of 20,000, 1 plus 0.3, because that's 30% as a decimal, raised to the t, and then I just simplified the 1.3. I know that this is my a, this is my b, this is my t, also known as x. I put t here because at this point, we don't have a number value. We don't know how many months out. So then it says identify the values of a and b from your function, relate each value. So a is my initial earnings, that's the $20,000 that they made in January. And then the growth rate is the b, and that's the 1.3, right? So I identified them, and then I related them to the context, initial earnings, growth rate. Then it says to create a graph that shows the earnings from the clothing store for 4 months since January. So in my calculator, I would do, I'm going to pull my calculator up here. Oh, that glare is terrible. I'm so sorry. Let's put it down here. Okay, I would do 1.3. I would hit x to the y, choose 1 equals times the 20,000, and I'm going to get $26,000 would be their goal after the first month. Then for the next one, I would do 1.3, hit x to the y, put 2 for my value of that t, and then I multiply times $20,000 again, and I get $33,800. Then for the third month, I get $43,940. And for the fourth month, I get $57,122 something or other. Just leave it at that. So I'm going to graph these. So the first month, I'm going to go to like 26,000. Oh, for our increments really quick, these were by 5s, right, on our y-axis, and these are by 1s. This is called an axis break. And that just is so we can kind of start here at 20,000 instead of trying to start all the way up, right? That would be a giant graph. Once you get past this axis break, you have to do equal increments. So that's why it goes 20, 25, 30, 35, and so on. So I graphed the first one. At 2 months, they want to have earnings of $33,800. So that might be something right here. At 3 months, they want to have earnings of $43,940, so that might be right there. And at 4 months, they want to have earnings of $57,122. So then the last step is to connect these with a smooth curved line. Connect it better that way. So that's what your graph would look like. Okay. Oh, I'm going to turn this light off. Maybe that'll help. So that's page 1. Page 2. They ask us, they say, use your function in item 1 to determine the exact amount of earnings the store should have in 9 months. Oops, sorry, that's up here at the top. So I'm going to use my formula, y equals a times the quantity 1 plus r raised to the t. Y equals 20,000. Remember, that was their starting earnings. 1 plus 0.3. This time we're going to raise it to the 9. So y equals 20,000 times 1.3 to the 9th power. So again, I'll put in my calculator. (1.3) raised to the 9th power times 20,000 equals, ooh, they have a lofty goal there, $212,089.99. So y equals $212,089.98. That's their goal. Okay, for items 5 and 6, it says, graph each exponential function on the coordinate plane provided. Make a table of at least 4 values and graph each function below. Do not use a graphing calculator. Okay, we have never done that, so I have no worries about you guys doing that. I put hint, create a table of values first based on the function, then plot your ordered pairs and connect with a smooth curve. Okay, so here we go down here to our tried and true -2, -1, 0, 1, 2. So our function is this one. I'm going to have to zoom out, aren't I? This 1/3 raised to the x times 3. So remember, for 1/3, first you must do 1 divided by 3 equals, and then I'm going to hit x to the y, raise it to the -2, and then times 3 is going to give me a positive 27 for my first y value. Start over. 1 divided by 3 equals, raised to the -1, times 3 equals 9. 1/3 to the 0 power is going to be 1, right? Because anything to the 0 power is 1. 1 times 3 gives me the 3. 1 divided by 3 equals, raised to the first power equals, times 3 equals 1. And then the last one, 1 divided by 3 equals, raised to the second power, times 3. That's 0.3 repeating, which is the same as 1/3. And if you put 0.3 repeating, I mean, that's fine. So now let's graph this. We can't do -2, 27. It's not going to fit. So that's fine. We just won't graph that one. -1, 9. 0, 3. 1, 1. 2, 1/3. So you can see a nice exponential decay showing here. You connect it with a smooth curve, and that's all I'd be looking for on the quiz. All right, let's do this next one. I have my tried and true -2, -1, 0, 1, 2. So on my calculator, I'm going to do 2 to the -2 equals times -1, and I'm going to get -0.25. And then I'm going to do 2 raised to the -1 equals times -1. I get -0.5. 2 to the 0 power is 1. 1 times -1 gives me -1. 2 to the first power is 2 times -1 is -2. 2 squared is 4. 4 times -1 is -4. And you might be wondering, like, where are you getting that -1? Okay, remember there's a -1 hiding here. So the last step is to multiply times that -1. So now let's go ahead and graph this. So I've got -2, -0.25, -1, -0.5, 0, -1, 1, -2, 2, -4. So I've got this smooth curve going that way. Remember, this negative sign also tells us that we should have a reflection over the x-axis. So that's why this is flipped over the x-axis and going that way. All right, next page. The table and graph below show the remaining amounts in milliliters. of 2 unknown liquids recorded during an evaporation experiment. Use this information to complete items 7 through 10. Okay, so we've got liquid 1. We can see that when we're going from the weeks, it's increasing by 1, which means it started out at 10,000 milliliters. And then if you subtract 10,000 minus 755, you get 2,450. So that tells us that it was subtracted by 2,450. And then you can look and see, oh, that's my rate of change. And then this would just end up at 0, right? Because you would subtract the 2,450, which means at week 5, you're going to have 0 because you can't go lower, right? You're just going to run out. Okay. And then for liquid 2, we have an exponential. We have a decay situation here because it's evaporating. And if you fill in these increments, right, you can see that my y values, remember we did this on the homework, we went in and we were like, okay, what were our y values? So I'm just going to try to say y values over here. I start out at 10,000, then I'm at 5,000, then I'm at 2,500, then I'm at 1,250, and then 1,250 divided by 2, then I'm at 625, and so on, right? So what you can see is happening here is they are dividing by 2 each time, right? So we would say divide by 2. Okay, so now we have situations happening here. So for liquid 1, it says create a function for each liquid's rate of evaporation. So for liquid 1, I'm going to write it underneath here because I found out earlier I'm going to run out of room. My linear function, because this is linear, right, this is going to constant rate of change, is going to be y equals negative 2,450x plus 10,000, because that's where I started. I started out with 10,000 milliliters. For liquid 2, my exponential function is going to be y equals 10,000, because that's my initial amount, times the quantity, or times 1/2 raised to the t power, because I know I'm dividing by 2, right? And my y-intercept happened to be 10,000. So that's going to be my exponential function. And the way I got this 1/2 is because I took 1 minus 0.5 because it's being divided by 2, and that's how I got 1/2. Which liquid is the first to have 2,500 milliliters or less remaining, and during what week does this happen? So let's look here. If I fill in the rest of the weeks for this graph, I'm down to 2,500 here in week 2. And down here, I'm not going to get to that until around between week 3 and 4. So the liquid to get there first, to lose that much first, we would say liquid 2 will have 2,500 milliliters or less during the second week. Or let's not say during the second week, let's say at exactly 2 weeks. Liquid 1 will have 2,500 milliliters or less sometime between week 3 and 4. So our answer, which liquid will have it first? Liquid 2 will have 2,500 milliliters or less first. So we found out what happens with liquid 2, we found out what happens with liquid 1, and then we declared that liquid 2 would have that amount or less first. Okay, we're getting closer. Next one, or next page. Ben claims that liquid 1 will always have more liquid remaining each week than liquid 2. Is Ben correct? Mathematically explain your reasoning. So let's go ahead and look at what's happening here. And we kind of already hinted at this before. When you look at this table compared to this graph, okay, remember this is a constant rate of change, which means that eventually liquid 1 is not going to have anything left. But over here, this is decreasing by halves, and we've talked numerous times that even though we're dividing by 2, we're never going to run out. It's never going to be at 0 exactly. It's just going to be smaller and smaller and smaller and smaller amounts. So Ben's claim is incorrect because liquid 1 will eventually run out, whereas liquid 2 will continue to have smaller and smaller microscopic amounts. So our answer is Ben is wrong. I'm going to put that in all caps. Sorry, Ben. Okay. Liquid 1 will run out while liquid 2 will just continue to have smaller amounts. So that's our mathematical explanation. The reason that word mathematically explain your reasoning is in there is because I don't want you to just be like, Ben is wrong, and then not explain how you know that. I need you to explain to me how you knew that that was a thing. Okay, determine the exact amount of milliliters remaining for each liquid after 2.5 weeks. Good thing we have those functions, right? So let's do liquid 1. Our function was y equals negative 2,450x plus 10,000. So we're going to do y equals 2,450 times 2.5. Excuse me, negative 2,450 plus times 2.5 plus 10,000. So when I get out my trusty phone calculator, 2,450 negative times 2.5 equals plus 10,000, and I get 3,875. Okay. Liquid 2. Remember our function was y equals 10,000 times the quantity 1/2 raised to the t. So we're going to have y equals 10,000 times 1/2 raised to the 2.5. So I'm going to do 0.5 raised to the 2.5 and get this fun number times 10,000. And I'm going to get 1,767.77 is what I'll say there. So y equals 1,767.77. So we have the exact values. Let me put milliliters for each liquid. We've got the correct response, correct supportive reasoning. Ta-da! All done. So that is your study guide. Again, I will be posting just a picture of this. If you made it through this whole video, thank you. Oh, one more thing I want to add here. What's the same thing as y? F of x, f of x. I could put those there. And then for these, I also could have had f of x, 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 f of x. All right. Thanks for watching, guys. See you tomorrow.